So welcome to Motion Graphs Part 2. We are finishing that packet that we have already started. Alright, so flip to the middle where you see the speed time graphs at the title, or page 7. Okay. And note that the only difference on the graphs is what's on the y-axis. Alright, so when looking at a speed time graph, what a horizontal line, what a diagonal line means is different than on a distance time graph. Okay? Because on all of these graphs we have speed, or v, on the y-axis. So the higher you are on the y-axis, the more speed the object is undergoing. Okay? So a horizontal line in this case no longer means that the object isn't moving, but that it's moving at a constant speed, or an unchanging speed. Okay, if you wanted to show no speed on a speed time graph, it would be a horizontal line, but it could only be at 0. It's the only way you can show that it's not moving on a speed time graph. Any line above 0 means that you are moving at a constant speed. Okay, then the diagonal lines mean that your speed is increasing at a constant rate and or accelerating. And this time the backwards line actually doesn't mean backwards, it just means that your speed is decreasing or you are decelerating. Okay, so have to keep in mind that on a speed time graph, these lines indicate what's happening to the speed. Right? Is the speed increasing? Is the speed decreasing? Or is it staying the same? Whereas the graphs we worked with before were distance time graphs, and the y-axis and what was happening told you what was changing about distance. Okay? A little more. So on here, it's just kind of a summary of a speed time graph. Just keep in mind this is a faster acceleration, okay, whereas this is a slower acceleration, alright, doesn't mean, so these are both speeds, and one of them is showing speed increasing faster, which means you have higher acceleration. Excuse me. So, and then on this graph down here, we have a steady or fast acceleration, constant speed, a slower acceleration but still accelerating, and then slowing down or decelerating. You could think of this graph would be a representation of you leave the stoplight, you speed up quickly, kind of let your foot off the gas to move at a constant speed, realize you haven't made it up to speed limit, so then you go a little bit, accelerate a little bit more to get up to the speed limit, and then you hit the next stoplight, so you have to slow down. Something like that. So what I'm going to do is I will, like last time, I will use this to be your online assignment, except there are some more practice after this, so you know we're not done with this slide. But just keep in mind that in the online assignment, when it refers to graph E, F, G, and H, these are graph E, F, G, and H. And these are all speed time graphs, okay? So here are some comparisons between distance and speed. So look at the graph above. It shows 3 runners in a 100-meter race. So and also note what is on the y-axis. So this goes back to your distance time rules. Okay? So which winner won the race? And explain your answer. So if you notice, all of them end up going the same amount of distance, so which one gets to that distance first? Hopefully you're saying Albert, because it takes him less time. Okay? And then which runner stopped for a rest? Now on a distance time graph, we can see stopping with a horizontal line anywhere on the graph. So hopefully you would say Charlie, and because of his horizontal line. Then how long was the stop? Explain your answer. So again, you have to look at that horizontal line, but then use the x-axis, where time is, to figure out how long. So it starts at 8 and ends between 12 and 14, so we'll call that 13. So 13 minus 8 equals 5 seconds. We looked at time. And then how long did it take Bob to complete the race? So when Bob reaches the finish line, that is at 14 seconds. You can tell that from the x-axis. And then calculate Albert's average speed. Find the distance and the time first. Okay, so V equals S over T. Then Albert is right here. The distance on the y-axis is 100 meters. If you read it off the y, that's 100 meters. And then the time is 12 seconds. Okay, so 100 divided by 12 would be 8.33 meters per second. Okay, so those are some things that you can do with graphs. Let's look. So this time we have a speed time graph. And then choose the correct words from the following list to describe the motion during each segment of the journey to fill in the blanks. The bus is blank. Its speed changes from, so segment 0 to A, speed changes from 0 to 10 meters per second in 5 seconds. Okay, so we see that it goes from 0 to 10 meters per second. So its speed increased. So we would say that is accelerating. Okay, segment AB, the bus is moving blank of 10 meters per second for 5 seconds. So this time, if you notice, segment A to B is horizontal, so that's maintaining the same speed or a constant speed. And then from B to C, the bus is blank. It's slowing down from 10 meters per second to rest. Okay, so we started out at 10, we end at 0 meters per second, so our speed decreased, so that would be decelerating. And the bus, segment C to D, our speed is at 0, so the bus is, it has at rest, it has stopped. Okay, and then D to E, so we go from 0 to 5 meters per second, so we're increasing speed again. That would be accelerating. Okay, and then what would E to F be? And that, again, we stay at 5 meters per second. E to F would be a constant speed. And that's it. Just kidding. Okay, so that's the end of this. Make sure you fill out the online form based on the multiple choice graph question from a couple of slides before, and I will see you in class.